Hi, we're Team 206, Yearn to Learn, and this is our BRG presentation. I'm Sean Egan.
I'm Derek Oster.
And I'm Christopher Caston.
And here's Derek with the introduction.
So really this introduction is just explaining the tasks that we completed over the course of the semester during the product development process. We're going to go into detail for each of these tasks throughout the presentation. So we get this started with the project management. This is the Gantt chart that we use throughout the process. This looks very similar to the one that we showed you in the DP1 presentation. Obviously the most changes happened between the DP1 and DP2 presentations, namely extending the economic analysis task and making a lot of tasks parallel. The only difference between that Gantt chart and this one is the addition of the BRG Bonanza Showcase. This task was added once we were informed by Dr. Clark that this would be part of the entire project, and we added it right there on December 6th. This right here is the DSM. This was a little less helpful than the Gantt chart, but it did help the team visualize the parallel tasks that we created during the DP2 portion of the project. This really helped the team focus on what it is that we needed to complete and when we needed to complete it. So as we move from the management, we move into the planning of the product. This was very early in the process, and this is when we were deciding what it is we wanted to do with our BRG. We decided we wanted to market it into the second graders because we thought this was going to be a very large market, and we thought we could sell more as opposed to middle schoolers and high schoolers. By doing this, we also thought we were going to get some easier production, as we're going to be doing it less technical stations and more simple STEM-based stations. So we can see here, biggest focus for us was making it a game. By doing this, we also wanted to make it replayable, meaning the user could play it more than once, over and over again, and get a nearly different experience each time. The worst thing we could really think of is making a BRG that the user plays it once, knows how to win, never wants to play it again. So that was a big priority for us. The other big priority for us was safety. We wanted to be CPC certified, or else we could not market this, especially towards young children. So replayability and safety were the biggest things for us, and we actually see that from our quotes from some of our potential customers. These were the priorities for us, and we really wanted to make sure that the BRG we created focused on these. So then moving into the intellectual property, this was a DP2 task that we really wanted to look at to see we're not infringing on anything. The biggest red flag came in our second station, the teeter-totter. This was very similar to the tape suspended balance patent. Luckily, this patent was lapsed and we did not infringe upon it, but this did open the team's eyes onto the possibility of patent infringement and how scary that was. And watching this and kind of being cognizant of the whole patent infringement was the biggest thing for us. So as we became aware of that, we just started to develop concepts and stuff, and Sean will go into that with our concept development of stations 1, 2, and 3.
So for Station 1, we as a group decided early on that we needed to give the ball some height or other form of potential energy that it could carry through the rest of the stations with. So as you can see on the left are a lot of the original early CAD models that we as a group came up with to try and give the ball a lot of height. Featured here is the CAD model that we stuck with as our main theme, our main idea moving into DP2. And on the right you'll see our CAD model for our prototype that we built recently for the BRG Bonanza. A lot of these ideas really worked well together to get the ball a lot of height, but this was the best idea for our BRG. And we did some FMEA analysis, which I'll talk about more later, but the materials we used to construct it actually worked fairly well. We used chalkboard, plywood, and an Arduino with a servo motor to raise the elevator. And all that worked together fairly well, but just changing the materials and the method of construction would probably be better moving forward. But now to Station 2. So for Station 2, we wanted to stick with our math-themed idea of the trivia elevator from the first station. But with this one, we decided to go with a balance beam of sorts. And as you'll notice, our final prototype design is pretty similar to the one we came up with early on because we realized it was actually a pretty fun idea and the kids would enjoy. They would draw a card that would tell them to balance, let's say, 3/4 masses on this side, using only 1/4 masses on this side. So it was a lot of fractional work. We're targeting second graders, so we really wanted to just reinforce basic concepts. And again, we had a very sturdy prototype, but moving forward we did more FMEA analysis, of course, and a change in materials used, such as injection molding, would probably be better moving forward. But for now, it was a sturdy and good prototype. But on to Station 3. Station 3, we decided as a group that because we're targeting younger kids for our BRG, we didn't want it to be only about math or we wanted it to be more fun. So as you'll see in Station 3, many of our early ideas were more problem solving, more games, puzzles, stuff like that. And we actually ended up going with an earlier model seen here for our final prototype for the Towers of Hanoi problem, which is a age-old logic problem about moving blocks from one peg to another without stacking a bigger block on a smaller block. We know this is a repeatable game, but what we wanted it to do was to teach the kids algorithm development or just more efficient problem solving by repetition. But onto the entire BRG. Seen on the left is our BRG that we presented at the BRG Bonanza, and on the right is our final CAD model of all the stations. You can actually see the flow of the stations pretty well in this drawing file here. Our total BRG actually worked really well. We got amazing feedback from peers and evaluators at the Bonanza. They really enjoyed the game aspect that we had, and moving forward, we had a lot of good feedback from that we can do moving forward to improve it. But overall, we would say it's a huge success, and we actually have a viable product moving forward. So after the BRG Bonanza night, we decided to evaluate our what motivated us to make the choices we made. And as you can see here in our industrial design sheet, this is from the ergonomics section of our industrial design. So when it came to the ergonomics of our product, we really wanted to focus on the quality, the novelty, and the safety. Those were our top 3 priorities because we didn't want this game to be boring for the kids. As Derek mentioned earlier, we wanted them to be able to play it over and over. So you'll see how important this was to us. But safety, all the way to the top of the bar, was an absolute necessity. We could not have done this project if it was not safe. And then on to architecture. We purposefully designed our BRG to be very modular. We wanted a couple large chunks that were not well integrated in order for the teacher to be able, or any potential user, to be able to switch out chunks if they wanted to replace them with new ones or make a new one altogether. But we also were planning for expansion packs. If we were to keep moving this project forward, we would sell different expansions, such as more card decks for stations 1 and 2, or just for easier maintenance, as you can see there. But now on to Chris. He's going to talk about the economics of our project.
So we decided that we wanted to have our selling price of our BRG be at $50, and the way we estimated this cost was by doing additional research on other similar products to our BRG. We found with an EDO Science Electro Challenge, it cost $34.99. Then we found an Engineering Discovering STEM's Simple Machines, which cost $84.99, and a STEM Play, which cost $28. So we fit perfectly in the middle between all 3 of those, is why we don't feel that it is too high or too low of a selling price. Next, we have a variable cost of $30. How we estimated that was trying to figure out what material early on that we wanted to build our BRG out of. In the end, we chose particle board and dowel rods, essentially, and hot glue to assemble everything together. So that fixed cost varies a little bit due to the fact that we had to buy sheets of plywood to assemble our prototype. Next, we have our fixed cost, which we were provided by VTEPs of $11,250 per year. And then we did a rough estimation to figure out how much profit we could possibly make. So we estimated that we had a team to help assemble BRGs weekly, that we could probably produce around $50,000 or 50,000 BRGs per year, which would give us a grand total of $9,988,750 in profit. As you can see, we decided not to go with a variable style of profit, as we felt that keeping it open would allow us to gain more revenue in overall. So going to our economic viability analysis, we, Team 206, wanted to ask asked for a loan of $1,066,806 million. This was comprised of everything that we had to pay off over the first year, including paying workers, cost of materials and assembly of our BRGs, and that fixed cost. We wanted to pay our loan off over years 2 and 3, as we believe that's when we want to start selling our BRG and when we can start bringing in revenue, and overall when we can start paying off. So using that, paying off through 8 quarters, we found our annuity per quarter would be $218,000, or $218,900.77. And if that paid off over the 3 years, we would be left with about $626,294 in profit overall. So moving forward, we would like to do a few things differently. First, we would like to change the materials that we use to produce our BRG. We don't believe that particle board, dowel rods, and hot glue is the most effective way to assemble a game meant for rowdy kids. So in the future, we would like to move on to injection molding with plastic, as this will eliminate a lot of the little parts and we can just have big chunks, making assembly easier. It will make our BRG lighter, and we can make it out of colors which will be aesthetic for children. It will also provide sturdier connection in between the stands, which will allow the ball to move easier through the whole BRG. We would also want to do further testing. These BRGs do have to be endurant and durable. They have to be able to withstand what a second grader would put it through if that's accidentally kicking it, maybe resting on it, putting an object on it. So we would want to do stress analysis to see where a lot of our critical points are, where they could snap, or where we could fail and the BRG could break. Lastly, we want to make our stations possibly lower to the ground. At the moment, they're pretty high up, which causes the ball to bounce around a lot when trying to move down from station to station. Lowering it would allow for easier transitions and overall would mean that there would be more successful chances for the ball to make it all the way through. So in conclusion, we believe that we were able to build an economically viable product that was open to a very wide market, which is the second graders. We believe that we could penetrate that market a lot easier than a more high school orientated market. It appeals as both an educational and aid and a game, so it can be replayable, it has educational benefits, and it should be fun to play. The team met nearly all initial goals. Basically, essentially what I just said. We wanted to make it a replayable game that was safe, marketable to second graders. The only areas that we fell short on were essentially construction, as we only had, again, particle board, hot glue, and dowel rods. And lastly, we believe that our BRG is an effective tool to show that the product development process really works.